Hello again, everybody. We're going to finish out our chapter 4 talking about writing polynomial equations. Up to this point, we've been given equations and we've broken them down by factoring or looking at our graphing calculator and found the zeros, roots, x-intercepts, solutions. Now we're going to work exactly backwards from that. Before we do that, we need to talk about something called conjugates. We're not conjugating like you would maybe in foreign language class, soy, aries, ace, somo, son, things like that. In math, conjugates mean opposites. We have conjugates for irrational numbers, which for our purposes this year are going to be square roots, and complex numbers, which is our imaginary I. So because conjugates are opposites, they have the exact same stuff, just a different sign in the middle. So we have -4, 3i, one's plus, one's minus. +3, square root of 2, one's plus and minus. +3, 7i, one's plus, one's minus. So let's take a look at these first ones. It's asking you to give the missing zeros or conjugates for anything that needs one in this top set. This is something that will be asked on your test as well. So looking at number 1, I see 4i. 4i needs a conjugate. The opposite of a positive 4i is a negative 4i. In number 2, I see 5 minus 2i and 6i. So the conjugate or opposite of 5 plus 2i, 5 minus 2i is 5 plus 2i. And the opposite of a positive 6i is negative 6i. Number 3, we have a radical 5 and a 3i. So those two need conjugates. The opposite of 2 plus radical 5 is 2 minus radical 5. And the opposite of 4 minus 3i is 4 plus 3i. So let's take a look at the ones they gave us. We need to find its conjugate and then multiply them together. So right now we have x equals 2 plus radical 5. The conjugate to that is 2 minus radical 5. So to write them as factors, we need to move everything back over with x. The opposite of a positive 2 is a negative 2, so we're subtracting 2. The opposite of adding radical 5 is subtracting radical 5. So we have x minus 2 minus radical 5. Over here, we subtract 2 and add radical 5 over with the x. So we have x minus 2 plus radical 5. Now I need to multiply all of this together. So I'm going to rewrite this over here where I have some room. Now remember, you can distribute, you can use the multiplication method, or you can use the box method. And I'm going to use the box method. So we have x times x is x squared. X times negative 2 is negative 2x. X times negative radical 5 is negative x radical 5. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times negative radical 5 is positive 2 radical 5. Radical 5 times x is x rad 5. Radical 5 times negative 2 is negative 2 radical 5. And positive radical 5 times negative radical 5 is negative square root of 25. And hey, we can take that square root of 25, which makes that answer negative 5. From here, remember, we add like terms on the inside. So x squared, check. Negative 2x and negative 2x is negative 4x, check. The x rad 5 and negative x rad 5 add to 0, so those are gone. Negative 2 rad 5 plus 2 rad 5 add to 0, so those are gone. And then 4 plus negative 5 is negative 1. And this is our answer. And you notice in our answer that we don't have any square roots anywhere. And so that's the purpose of using conjugates. Conjugates get rid of the terms that have the square roots or the i's in them. And that's why we like to use them. You notice that we've had answers in our last section that had square roots or i's in them or both. But the polynomials they started with didn't have them to begin with. And this is why. Let's try the second example. Negative 3i. So right now we have x equals negative 3i. The conjugate of a negative 3i is a positive 3i. I'm going to move that back over with the x, so the opposite of subtracting 3i is adding 3i to both sides. So this factor is x plus 3i. This is subtracting 3i from both sides. So we have x minus 3i. I'm again going to rewrite this so that I have some room. This time I'll distribute. X times x is x squared. X times negative 3i is negative 3ix. 3i times x is positive 3i times x. And 3i times negative 3i is negative 9i squared. All right, let's simplify. So negative 3ix plus 3ix adds to 0. The other thing we want to remember is I squared. I squared, remember, is equal to negative 1. So over here on the right, we actually have negative 9 times negative 1, which is positive 9 with that x squared. And so this is our final form. Number 6. Right now we have x equals negative 2 plus 3i. So the conjugate, remember, we keep the negative 2, but we write minus 3i. So to bring that back over with x, we add 2 and subtract 3i from both sides. So we have x plus 2 minus 3i over here on the left. And then on the right, we're again adding 2 and adding 3i this time. So we have x plus 2 plus 3i. I'm going to take those two factors and multiply them together. I'm again going to go ahead and use my box method. minus 3i x plus 2 plus 3i. So x times x is x squared. X times 2 is 2x. X times negative 3i is negative 3ix. 2 times x is 2x. 2 times 2 is 4. 2 times negative 3i is negative 6i. 3i times x is 3ix. 3i times 2 is 6i. And 3i times negative 3i is negative 9i squared. So let's simplify. And starting with the x squared, it has no other like term. 2x plus 2x is positive 4x. 3ix and negative 3ix add to 0. 6i and negative 6i add to 0. Negative 9i squared, remember, is negative 9 times negative 1, which is a positive 9. So 4 plus 9 is 13. And that is our final answer. This is where we're going to stop for today. We'll pick up with the next section in class tomorrow and continue from there. Have a great night.